is a indexing SDK for blockchain data. And the motivation for this workshop is essentially current complex and massive data that we have to deal with if we want to be working with historical data and make the analysis of it. And it's really hard to query directly. And even if it's possible, then you still have to have a certain understanding of data structures, as well as the, yeah, you still have to do some structuring. And you also have to use some tools, but like you can also leverage an AI as a tool because it can help interact with such structured data with simple natural language requests, so that as someone who's not technically business owner who wants to get the insights from on-chain data, you don't have to worry about knowing those technical intricacies. So by combining blockchain data with AI, you can get like user-friendly querying tools. So the goal of this talk would be to demonstrate a practical integration of using open source tools connected together in a completely local setup, and yeah, provide an accessible starting point for exploring data exploration with the AI. A preamble. This is going to be a beginner-friendly overview prepared by someone who is not specializing in AI. So if you know more, if you can suggest some of the things for further research, please do after this workshop. I'm a full-time student and I want to be staying as one. So there's going to be no, there was no custom development involved during the presentation of this workshop. It's just those open source components stuck together and working to essentially make this proof of concept. And obviously, it's not production ready. So you shouldn't be going with that. You shouldn't be pushing it to your production apps. So this is what I'm going to showcase. So this is a process of the things that I'm going to be showcasing. So we're having a, in parallel, we're going to be running a local node. We're going to be indexing certain data from it. And in parallel, once it's going to be indexed, so indexing essentially, if you don't know, it's structuring the unstructured. Blockchain indexing is structuring the unstructured data and saving it in a certain structured format, like a relational database. So on the right-hand side, we're going to be doing that, and in parallel, we're going to be creating and using an agent. I'm having it in double quotes because it's not going to be really an agent, because the agent is something that is able and capable of making the decisions autonomously. But like in my case, it's just going to be an AI-powered tool that's going to be just translating the natural language to SQL, and then interpreting the output from the database to a natural language result, so that's like easily readable. And this is what I'm showcasing on the left-hand side. So here, so essentially, this agent is going to be creating a SQL for further querying. Then we're going to be manually controlling it whether it should like execute this SQL command. And finally, it's just going to send the results to EVM, and then EVM explains what exactly the outputs of that. So components that we're going to be using. We're going to be running a substrate node with palette, revive, and revive RPC configured. This is a RISC-V virtual machine. It's I'm going to be spamming the smart contract with a lot of data, and I know that RISC-V is going to be capable of handling such kind of data. So I chose that. So the PVM is not a part of this talk. So be sure to check the talks of the fellow speakers on that part. I'm going to be spamming with Hardhat. Going to be using SubQuery Indexing SQL for indexing. Going to be hosting LLM on Alama. And in order to build this agent, we'll need a OpenAPI compatible endpoint, and Olama gives this to us. And as a framework for building an agent, we're going to be using LangChain itself. Yeah. So demo time. So we're going to be starting that with Hardhat. Let's start a node first. So I'm building a subsheet node with palette revive. So this is the config. We also need a proxy server so that we can deploy the contract and interact with it. For that, I've built if RPC in advance. And it's a very simple contract that we're going to be dealing with today. It looks like that. So essentially, it's just a number, an event number stored, and actually a single function that we're going to be using for store. So it's just going to be accepting a number, saving it to the storage, and then a certain number stored event is going to be emitted. So that's it. Very simple. So we can go ahead and run node. So I have started it. We can also check if it's running. In case you don't know, this is a Polkadot.js UI. Could be usually considered as a blockchain explorer for substrate blockchains, but I'm having issues with the UI for some reason. I'm not seeing the blocks. Oh yeah, here it is. So the node is up and running. So we can start spamming it. So I use Hardhat for that. I'm going to be deploying the smart contract that I've just mentioned, and then we're going to be just interacting with it. So this is a script for interaction. We're having an infinite loop here and dealing with infinite loops. And yeah, just going to be taking a random value and call the store function with the random value. So this is command to do it. So I'm deleting my previous deployments first. I'm deploying a contract, and then I'm starting the script. So if I start running it, I'm having the contract built. And yeah, we should have it started anytime soon. In the meantime, I can proceed to the next part probably. Oh yeah, that's already started. So we can see that we started spamming, and in the Explorer, we're also seeing the events appearing. So there's a lot of data that we can actually index and work with. So it's cool. What's next? Once we have node started now, as well as the spamming of the contract, we can start setting up the indexer itself. So again, an indexer, it's a service which is just structuring unstructured blockchain data into something that could be worked with. So this is a folder for the indexer. So that's going to be a pretty simple setup. So this is a file to essentially specify a data schema that we're going to be dealing with. So since it's only a number stored and only simple number that we're going to be storing, that's going to be a single entity. So as you can see, it's block height, number, and sender. This is the only data attributes that we're storing for each transaction. A second thing would be to configure the actual endpoint that we're going to be working with. So it's locally hosted node. So that's the endpoint. And the chain ID is that. You can trust me on that one. And what's going to be done is we just want to handle this specific event, which we've just created in a smart contract, and yeah, pass this event as a parameter to a handle log function. So this function is just a writer to the database, essentially. So as you can see here, it's creating a new entry for, once it's seeing a new event, it's just creating a new entry in the database. For ID, it's using the transaction hash. And for number, it's using the value that's being used. So if we just start it, we'll see that and hope that the index is going to be doing fine. So, yep. So what's happening behind the scenes? It's really simple. We're just having a new database with a single table called number stored. So what we just did is essentially structured blockchain data to a relational database. That's it. And since we have a relational database that we can work with, and since this is, sorry for Web2 interfaces here, actually. That's probably not something that you would expect on Web3 conferences, but yeah, it is what it is. And since, yeah, it is yet a popular thing that a lot of companies are dealing with. There are, of course, a lot of out-of-the-box tools that could interact with that, including an agent SDK that we're going to be using now. So essentially what we want is query this data from the LLM, which is a simple thing because a lot of agents are capable of interacting with Postgres data. So proceeding to the agent side of things. So by the way, of course, like all of that is like locally hosted and run from my machine. It's not the most how to say the most performant machine ever. So it's capable for doing this local analysis, which might be useful for someone who's just who don't want to be dealing with a lot of computation. So what's next? Next, we start the agent itself. So let me go over the code of the agent. Hopefully you're seeing it. So I'm just going to be briefly describing what we're going to be doing. So we are starting in LLM. I'm using Olama, and I've picked this random model from the library. We're going to be connecting to a Postgres database that we're hosting in Docker for convenience reasons. We're also providing certain instructions in the form of a prompt. Together with that, we're passing a schema of the database so that LLM knows how to design the SQL query itself. And we're also passing a question, of course. So here are some of the functions that we'll need, but essentially it all comes to three steps of this agent. This chain of commands is to write a query, execute a query, and generate an answer based on the initial question. So those are the steps. They're gonna be yeah, executed sequentially. So yeah, we can start running the script. And I'm also having a few example queries prepared here. So the first one's going to be how many times the number was stored so far. I'm also giving it a hint to use for SQL, but let's try without that. So what's happening? It's trying to generate a SQL for our question here. So we can visually see and validate it. So it seems app metadata, join app metadata. For some reason, it wants to join the app metadata. Let's try to execute it and see if it works. It's 0. Wow. All right. Let's try again. Probably we don't need partitions by. All right, let me try to return the hint. Maybe it will help this. All right, yeah. So with a little help, it worked. Again, it totally depends on the LLM you choose. You have to probably teach it by providing an inference, but like for a default one that I've picked, it's working okay. So we can also test it on with the other queries. For instance, that one, what are the most frequently stored numbers and how many times was each of them stored. This is the SQL we received. Should be fine to me. Oops. Yep. Failed to execute. Cool. Let's try again. Don't use it for production. Failed to execute. Come on. So the reason it's failing is because master query ID. I don't know why it's doing that. All right, last attempt. Oh yeah, it worked from the third time. So yeah, here is the numbers, and here is the interpretation. The most frequently not stored numbers are those. So this might be very convenient for, again, those who are not really tech savvy and cannot even work with, or don't even have time and possibility to work with any tools or dashboards. And yeah, there is a good tendency to switching to chat-based analysis. So let's also work with the third query just to test it out. What is the last stored number that got stored? I'm also hinting it again to use a block height. So yeah, it worked from the first time. So it's cool. All right. So and on that point, I think this is all that I wanted to show you. So if we have time for, I don't know, open conversation discussions, any suggestions for further research or any things that I should look into as someone who's just yet experimenting with that, I would be happy to hear your suggestions or maybe answer some questions. Thank you. It took like less than an hour to configure all that. Well, you have to understand like probably the hardest part to configure is the indexer, because you have to know what data to deal with and how to handle it. But apart from that, it's easy. You can use it out of the box. Yeah. The context, you mean? Yeah, you can set it up so it learns. So yeah, you can set it up in the form of a thread, so it's having a context to work with, just like any LLM. Please. You can do it, yes. But do you want to use it? That's the bit. I wouldn't do it, no. I think I think it's important to understand that. Yeah, well, that's your probably risk appetite that you probably want or not. Or it's going to be a very good AI that you want to be dealing with if you want to be executing transactions. But like, I wouldn't personally do it. But I'm not a person who is having a huge risk appetite, like in general. No, I didn't publish it. This is essentially these are several repositories. This is the one for Houthead, LangChain, but like probably yeah, I can put it all together. Yeah. Yeah, I can make it public. Yeah. The data lock, like the chain locks. So well, I think it's what's the target audience here? So what we're dealing with is a chain data. It's not something technical and deep. It's not like traces. It's not like anything consensus related. It's really those like small, it's called business data points that are stored on chain, like blocks, transaction, and events. So the target audience is like rather who is interested in only that kind of data. If you are more into if you're in the development of like consensus and you need like good debugging systems together with detailed logs, then yeah, it would be possible to set up a data log, but again, like that's just a different target audience. But the question is whether, as a consensus developer and someone who need to work with logs, do you even need AI for analysis? Yeah, then that's going to be a good use case then. So again, I'm using LangChain here. So if you can check and see that, I'm probably sure that LangChain is already having the data docs supported out of the box. So if it does, then it's probably going to be possible. Yep. Sorry? Because it's a good, flexible framework that's having out of the box as a relational database adapter. So LangChain is it's not the most sophisticated one, not the most modern one, but it's just a thing that is able to easily showcase those sequential operations that are needed for this specific use case. There are actually like, of course, there is a next version of LangChain, which is called LangGraph. So if I'm having my steps sequential, LangGraph would be able to autonomously decide like which step should I execute next in order to achieve something. So this would be more autonomous, but since I want to simplify my use case a little bit, I use LangChain. Yeah, just for, again, for simplification reasons, mostly. Honestly, I picked a random one from a Llama library. No intentions to use Java specifically. Yes. The Kema. All right. Yeah. Maybe we should try it out. So I'm also curious in knowing if any of you having any experience previously, like whether it's actually a good approach to be structuring the blockchain data to anything like more structured, like a relational database, or is it something that we can use separately? Like the reason why relational databases are mostly a de facto standard for the indexes is because, first of all, it's easy to wrap the GraphQL service on top of it so that you're having those interconnected entities. And secondly, like indexers is something that is using a feature of relational database, the indexes themselves, so for faster querying. But like, I was curious if anyone in the audience have any experience with non-relational databases and indexing data and storing it in non-relational databases with work with it. So what are the results? Terabytes of data. So and have you been comparing it to relational database performance? Hmm. All right. Understood. Thank you. Any questions from anyone else?